A nozzle and flapper arrangement transmits the pneumatic signals in a pneumatic control system. Air is fed to the nozzle at a constant pressure of 1.5 to 2 bars through a restrictor. The function of a restrictor is to limit the airflow. When the gap between nozzle and flapper is minimum, the outlet pressure from the nozzle is maximum. When the gap between nozzle and flapper is maximum, the outlet pressure from the nozzle is almost equal to the atmospheric pressure. The curve shows the relationship between outlet pressure and flapper nozzle gap. The curve is linear only over a certain range. In this range, the pressure varies proportionally with flapper nozzle gap. The sensitivity of this arrangement is decreased by adding a negative feedback below, which reduces the flapper movement for a given input range. The output signal is fed back to the flapper through a below. It is termed negative as it moves the flapper back towards the original position. If the flapper is moved further away from the original position, then it is called positive feedback. The output from the flapper nozzle arrangement is small. It cannot be transmitted over long distances and cannot operate large equipment. Hence, a booster relay is used for amplifying the output signal. Air is supplied to the booster relay. When there is no output from the nozzle, the valve spindle opens the exhaust air passage and most of the air supplied leaks off. When the nozzle output is maximum, the valve closes the exhaust air passage. The supplied air comes out of the relay at high pressure of 1.5 bars. Thus, an increase in output from the nozzle results in an increased output signal from the relay. The diagram shows a simple proportional controller with booster relay. A set value of pressure, P sub S, is fed in one below. The measured value of pressure, P sub M, is fed into the opposite below. The measured value of pressure P sub M will be proportional to the measured variable. The variable can be temperature, flow, and others. Any difference in these two pressures, P sub M and P sub S, causes movement in the lower end of flapper, varying the output pressure. The output of the unit is proportional to the difference between the set value signal and measured value signal. The problem of offset in proportional controller is overcome by introducing an integral bellow opposite to the proportional bellows. A variable restrictor is placed before the integral bellow so that the integral action time can be varied. Additional integral below will introduce a positive feedback to raise the pressure, P sub 2, at a rate dependent on the deviation. Integral action will continue until the deviation ceases and there is no offset. Derivative action is obtained by placing a variable restrictor before the proportional bellow. This gives a faster response as the output is proportional to the rate of change of deviation. Derivative action has a stabilizing effect on the system and reduces overshoot.